Hello everyone, I'm Maria Ruiz Serrano and we are the Group 8. Today, we will discuss to you the importance of calculus in our life and what is calculus used for. So, may I ask you a question first? Have you ever wondered when I'm ever going to use this in real life during your calculus class? The answer is yes. Calculus is the language of engineers, scientists, and economists. It is generally believed that calculus was discovered independently in the late 17th century by two great mathematicians, Isaac Newton and Gottfried Leibniz. Calculus is a Latin word which means tome. There are two main branches of calculus. First is the differential, which helps us find the rate of a change. And then the second one is the integral, which is the reverse of the differential. So to learn more about the two main branches of calculus, let us hear Sean Sunga as he discusses the differential calculus.
Hello, I'm here to discuss the differential calculus and derivatives. So, let's go. Differential calculus. First of all, what is function? Function is a binary relation between two sets that associates to its element of the first set exactly one element of the second set. Typically, examples are functions from integers to integers, or from the real numbers to real numbers. Now, what is differential calculus? In mathematics, differential calculus is a subfield of calculus that studies the rates at which quantities change. It is one of the two traditional divisions of calculus, the other being integral calculus, the study of area beneath a curve. The graph of a function drawn in black, and a tangent line to the function drawn in red. The slope of the tangent line equals to the derivative of the function at the market point. The primary objects of study in differential calculus are the derivative of a function, related notions such as the differential and their applications. The process of finding a derivative is called differentiation. Derivative in mathematics, the rate of change of a function with respect to a variable. Derivatives are fundamental to the solution of problems in calculus and differential equations. In general, scientists observe changing dynamic systems, to obtain the rate of change of some variable interest, incorporate this information into some differential equation, and use integration techniques to obtain a function that can be used to predict the behavior of the original system under diverse conditions. We have different notation of derivative. We have dx, d over dx, dy over dx, f prime of x, and we have formula for derivatives. Del limits delta x approaches to 0, f of x plus delta x minus f of x over delta x. We use this formula to identify the derivative of a function, but if you are familiar with this formula is not always needed to identify the derivative of a function, because we have rules of differentiation. We have power rule, constant rule, trigonometric function differentiation, log rule, sum rule, multiplication rule, division rule, chain rule, higher order derivatives. And that's all for differential calculus. BASILAN will be going to discuss the integral calculus.
So I'm going to discuss to you about the integral calculus, but there are two things first that I want to share it with you. So the first one, integral calculus, deals with the theory and application of integrals. And the second one, it is the reverse process of finding a derivative. So let's proceed now to the notation to represent the integral calculus. This is the integral of f prime of x. dx is equal to f of x plus c. So this one, as you can see, it looks like a big S. So this stands for the integration symbol, or also called as the integral sign. So this f prime of x is called the integrand, while this dx, it shows the variable needed to integrate, while this f of x is called the general antiderivative of f, or also called as the original function from the derived function, while this c is called the constant. So let's go now to the basic integration rules or formulas, or also called the theorems on antidifferentiation. So the first formula that we have here is the integral of dx is equal to x plus c. So the second formula that we have here is the integral of a f of x is equal to a integral of f of x dx. So wherein a is constant. So this is applicable to any function with only have one term. So for our next formula, we have here the integral of f of x positive negative g of x dx is equal to integral of f of x dx positive negative integral of gx dx. So here, this is applicable to functions with two or more terms if f and g are functions determined on the same interval. So for our fourth formula of our theorems on antidifferentiation, so we have here the integral of x raised to the n dx is equal to x raised to n plus 1 over n plus 1 plus c, wherein the n shouldn't be equal to negative 1, because if n is equal to negative 1, we can't use the power rule, because this formula is also called the power rule.
So good day everyone. Today we will talk about how calculus is used in medicine. Calculus is used in medicine to measure the blood flow, cardiac output, tumor growth, and determination of population genetics, among many other applications in both biology and medicine, although sometimes less obvious than others. Calculus is always in this discussion. We will focus only on the way that a drug's concentration over time is calculated using calculus. In applications of differential equations, the functions represent physical quantities, and the derivatives, as we know, represents the rates of change of these quantities. Therefore, a differential equation describes the relationship between these physical quantities and the rates of change. In order for us to create a differential equation that describes the physical quantities of a drug in relation to the rate at which they change, let's consider the following variables. In order to create the rate of absorption, the equation must include the drug dosage, the absorption constant, and the drug's bioavailability. In order to calculate the rate of elimination, the equation must include the elimination constant, the volume of drug distributed throughout the body, and the concentration of the drug that is left. In order to model our concentration over time, the elimination must be subtracted from the absorption in order to calculate the amount of drug that is left in the body at various time points. Medical professionals need calculus. Without drug specialists in the pharmaceutical industry testing drug concentrations over time and modeling them using calculus, we would not have labels on medication that provide instructions for dosage use. Although the equation for each drug looks unique depending on its property and the patient's anatomy, calculus is necessary for medical professionals to have the ability to map the relationship between drug concentration in the body over time. So this discussion shows the impacts of calculus in the medical industry.
I'm going to discuss how calculus is useful in real life. Calculus is everywhere. The differentiation and integration of calculus have many real-world applications, from sport to engineering to economics to astronomy and space travel. Calculus in economics. Function and derivative of calculus are related to relevant concepts in economics. Economic research uses calculus function relationship, relation of economy, market prediction. Differentiation is used to find optimum solution of economics. Calculus are also used for maximum efficient or product or to minimize their costs. Credit card companies use calculus for monthly payment. Calculus in engineering field. Calculus initially development for better navigation system. Without use calculus, road, bridge, tunnel would not be safe as they are today. In robotic, calculus is used how robotic parts will work in given compound. Electrical and computer engineering use calculus for system design. Calculus is used to improve safety of vehicles.
Overall, calculus has a huge role in the real world. For most professions, learning it is the key to success. So this is why you can dismiss calculus as just as another inconvenience. So by hearing this lesson, I hope you learn a lot. Thank you for listening and God bless us all.